Let's look at some logarithms, or logs for short. So what are logs? Logs were invented by the Scottish mathematician John Napier back in the 1600s, and they are essentially the inverse of using powers and indices. So for example, we know that, for example, 10 to the power of 3, which means 10 by 10 by 10, is 1000. So here we have used an index, or indices, or a power. Logarithms are the inverse to this. So if I wanted to get log to the base 10 of 1000, what does this mean? Well, what this is really saying is, looking at the base 10, 10 to the power of what would give me 1000? That's what this is really asking you. Log to the base 10 of 1000, the value of that is whatever number I have to put 10 to the power of to get 1000. So we know already that 10 to the power of 3 is 1000. So therefore log to the base 10 of 1000 is equals to 3. Now what is the point of all this? Logs generally makes calculations with massive numbers, or a massive range of numbers, a lot easier to deal with. We see this a lot in modern day science. For example, the decibel scale. The decibel scale is used to measure sounds, and a sound, any sound from a really quiet noise to really loud noise, any sound can range from, let's say, 0.000000001 unit up to having a power ratio of 10 billion units and even more. Now this is a very wide ranging scale here, from 0.0000001 unit to 10 billion units. But by getting the log of the power ratios, what we're actually doing is creating this decibel scale, which ranges much more neatly from -100 to 100. So rather than having to deal with a scale that goes from 0.001 0.000000001 all the way to 10 billion, we just have to deal with a scale from -100 to 100. So you can see here that by calculating the logs of the power ratios, we have simplified the values and created a much smaller range, and also simplified our calculations. The pH scale for measuring acids and bases, and the Richter scale, which we use to measure earthquakes, are also examples of logarithmic scales. Let's have a look at some of the basics here. So as we've already said, logarithms is an operation that's the inverse to indices. So if we're using indices, we have index form, and logarithms, we have logarithmic form. So for example, in index form, the example we've already used, we know that 10 to the power 3 is equals to 1000. And if we write that in logarithmic form, we would say log to the base 10 of 1000 equals 3. So the first idea is to become familiar with how to go from index form to logarithmic form, and from logarithmic form back over to index form. So this brings us to the first log rule, and the most important log rule, which is how you go from log form to index form, or vice versa. So if you've got a to the power of x equals y, that's it written in index form. The same identity, the log to the base a of y is equals to x. So these two mean the exact same thing, but it's just two different ways of writing them, in index form and in logarithmic form. So let's have a look at some basic examples here. Look at question 1 here. Calculate the value of the following logs without using a calculator. So I'll just pick a few of these. We'll start off with the very first one here. We have part A, log to the base 3 of 9. And I want to figure out what that's worth. That has a value. The easiest way to figure out what that value is we put it equals to x, and then we'll use the rule that we had here, the rule to go from log form to index form and vice versa. So I'm going to bring that rule with me to the next page. In this particular case, if we look at this rule over here, the format I have is like the format on the right here, where a is like my 3, y is like my 9, and x is x. So I'm going to go from log form to index form using this rule. So rewriting this situation, this will tell me that 3 to the power of x is equals to 9. So what is x? We know that well, since 3 to the power of x is 9, 9 is 3 squared. So that means x must be equals to 2. So 2 is the numerical value of this logarithm right here. We can do one more example here. Let's, for example, look at this one here, part G. So log to the base 125 of 625. Now we want to figure out the value of that logarithm right there without using a calculator. So once again, we'll put it equals to x. I'm going to go back and get my rule just to keep an eye on it. We're using our rule, and following that rule, it tells me that I can call this 125 to the power of x is equals to 625. So 125 to the power of what will give me 625. Now, the good news is we've already looked at our indices, and our indices are quite strong, so we should have no problem in solving this. 125 we know is 5 cubed to the power of x is equals to 625 is 5 to the power of 4. So that's 5 to the power of 3x is 5 to the power of 4. We can equate our powers then and say 3x is equals to 4, x is equals to 4 over 3. So we know that 4 over 3 is the numerical value of this logarithm right here. So once you've got the hang of using this rule to go from index form to log form and vice versa, then it's time to look at some more of the rules. The first rule we're going to look at here, log to the base a of x plus log to the base a of y equals log to the base a of xy. So what that's telling us is if we were going to add two separate logs that have the same base, to do that we would multiply their arguments, multiply what's inside in the logs. Let's look at an example here. For example, if I wanted to figure out what is the numerical value of log to the base 2 of 4 plus log to the base 2 of 8. So one way we could do this is using the rule that we have above. Log to the base 2 of 4 plus log to the base 2 of 8. We're going to call that log to the base 2 of 4 times 8. Log to the base 2 of 4 times 8. In other words, that's equals to log to the base 2 of 32. Now, if I want to figure out what's the numerical value of this, it's much easier when I only have one log. So we've got log to the base 2 of 32. Put that equals to x. Using the rule we previously learned, 2 to the power of x equals 32. 2 to the power of x equals 2 to the power of 5. Therefore, x is equals to 5. So 5 is the numerical value of all of this, and we figured that out with the aid of this rule right here that we have on the top. Okay, so that is the first rule. When you want to add two separate logs, you multiply their arguments. Let's have a look at the next rule. Log to the base a of x minus log to the base a of y equals log to the base a of x over y. So when you want to subtract two separate logs that have the same base, you do that by dividing their arguments, by dividing what's inside them. So let's have a look at an example. Let's say I wanted to figure out the numerical value of log to the base 3 of 54, take log to the base 3 of 2. So using this rule up here, subtracting them, we divide the argument. So that would be log to the base 3 of 54 divided by 2, which we can call log to the base 3 of 27. Now we've got log to the base 3 of 27. What is the numerical value of that? Well, we can use the rule we've already been using. Log to the base 3 of 27. Let's put that equals to x. 3 to the power of x equals 27. 3 to the power of x equals 3 to the power of 3. Therefore, x is equals to 3. So 3 is the numerical value of this expression right here. To use that, we use the second rule, which was log to the base a of x minus log to the base a of y equals log to the base a of x over y. When you're subtracting, you divide what's inside the logs. Okay, one more rule. Let's have a look. Q log to the base a of x equals log to the base a of x to the power of q. Now it's important to understand here, it is just the x that is to the power of q here. If you have some number, q just represents any number that could be in front of the log, you can bring that number up as a power of the argument. You can have that number as a power of what's inside the log. Hence the q came from in front to being up here as x to the power of q. So let's have a look at an example where we could use this rule. Let's say I had something like 2 log to the base 3 of 6 take log to the base 3 of 4, and I want to tidy this up and get the numerical value of it. The first thing I want to do is notice the subtraction here. So I would like to subtract the logs using this rule that I have already used, but in order to use this particular rule, you cannot have a number in front of either of the logs. So because I have a number in front here, I have to deal with that first, and we can deal with this too by using this rule. So I'm going to rewrite this line as log to the base 3 of 6 squared. The 2 essentially came up as a power on the 6 minus log to the base 3 of 4. So this is log to the base 3 of 36 take log to the base 3 of 4. Now I can use the rule that tells me when I want to subtract two logs, I divide their arguments. So this is log to the base 3 of 36 divided by 4, which equals log to the base 3 of 9. So now we're in familiar territory. We have log to the base 3 of 9, and we just need to figure out the numerical value of that. Log to the base 3 of 9, let's put that equals to x. 3 to the power of x equals 9. 3 to the power of x equals 3 squared. So therefore equating the powers, x is equals to 2. So therefore 2 is the numerical value of this expression right here, and we figured this out using our log rules and converting it to index form and using our indices to finish it off. So this is it for the introduction to logs and the introduction to the log rules video. Your best bet is to practice some of these questions here, the more basic questions. You can check your solutions online, and once you're happy with the basic rules, then you should watch the video on how to solve log equations, introducing the change of base rule and the applications of logs. And for access to questions, solutions, graded quizzes and more, visit www.limmymaths.com.